Okay, so in this problem we had two samples of gases, and one gas had a mass of 0.34 grams and the other was 0.43 grams. And it asked which one has more molecules. So initially a lot of us were thinking, myself included, that this one had more molecules because it has more mass. But we forgot the fact that Avogadro's law says that no matter the size of the particle, they actually take up the same amount of space at the same pressure and temperature. So we have PV equals nRT. This is a constant, this is a constant, this is a constant, that one's a constant. So N has to be the same because in both cases, everything else is the same. So mathematically, it has to be the same. And the difference in masses there is just because the particles themselves have different molar masses. So which one has more particles? Neither. They are equal. Okay. Which one has the lowest kinetic energy? Well, you need to know the temperature and kinetic energy are the exact same thing. Temperature and kinetic energy are the exact same thing. If they have the same temperature, they have the same average kinetic energy. Okay, now it says which one is the fastest velocity. So you do need to know that kinetic energy equals 1/2 mv squared, and I think there's a correction constant in here. Or you could also use this equation, square root of 3 RT over velocity equals the square root of 3 RT over mass. So we see that in either equation, if the mass is bigger, then the velocity is going to be smaller. If the mass is bigger, then the velocity is going to be smaller. So which one has the fastest velocity? The lighter ones, particles A. And how can they have equal pressures if particle A's are going faster and B's are going slower? And what we see is B is hitting the walls less frequently but with more force, and A is hitting the walls more frequently with less force. And so that's going to result in equal pressures.